acid or the base reaction. All acids as well as all bases, they come in contact with the conjugate pair, that is the a base or the acid respectively, and they get mainly form the conjugation with original species. That is, for example, of HCl. सगळ्यांना माहिती आहे ना हायड्रोक्लोरिक ऍसिड when they get mixed with the H2O. So HCl is the acid, H2O is the base, and they produce the conjugate acid, that is the H3O, and plus Cl minus, it is the conjugate base. Okay. Then another example is the conjugate acids as well as the base are the NaOH. When they get mixed with H2O and they produce the OH minus, which is the conjugate base, and H2O plus Na, they are the conjugate acids. So this is about the conjugate acids as well as the base. Then what about the strength of acids as well as the base? The strong acids, they donate the H plus ions. They are more easily than, and the stronger acid as well as the weaker the conjugate base, and they get mainly associated with their acid. Then strong bases, they accepts H plus ions more easily, and stronger the base, the weaker the conjugate acid, and they get mainly associated with the base. Then what about the strength of acid as well as the base? If the stronger will be the acids, they always react with the weaker conjugate base, and if the stronger base, it will always react with the form of weaker conjugate acid. For example of H2SO4. What is the H2SO4? That is the sulfuric acid. They get mixed with NaOH, that is sodium hydroxide, plus H2O, that is the water, and they produces sulfuric acid. They can react with either OH or either H2O, that is they get react with water. That H2SO4 plus OH minus, they produce the HSO4 plus H2O. That is they have prepared the reaction. That is H2SO4 plus H2O, they produce the HSO4 plus H3O. So this is about the strength of acids as well as the bases. Then what about the atoionization of water? Water always undergoes some degrees of the dissociation. They forms H3O ions plus OH minus ions. That is 2H2O. It having the reaction H3O plus and OH minus. And the equilibrium constant for this reaction is the at 25 degrees Celsius. That is Kw is equal to H3O plus OH minus is equal to 1 into 10 raised to minus 14. It is in pure water. So that will be the atoionization of the water. Then atoionization of water, Kw is the temperature dependent, and it increases with the increasing temperature. Then atoionization of water, the example is H3O plus in a 0.053 NaOH solution. Since NaOH is a strong base, and therefore there will be the dissociation get complete. OH is equal to 0.053 molar, and they use the Kw to calculate the H3O plus. Then the Kw is equal to H3O plus or into OH minus, that is 1 into 10 raised to minus 14. 1 into 10 raised to minus 14 upon 0.053, that is equal to 1.9 into 10 raised to minus 13 molar. Then what do you mean by pH? Anybody? Yes, Pawar, what do you mean by pH? Vaibhav?
pH is the potency of hydrogen ion.
They are having the minus logarithm of hydrogen ion concentration, or they can measure the hydronium ion content of the solution.
Yes.
Or they are having the minus logarithm of hydrogen ion concentration. So log is the log base of 10, not in a natural log. So H3O plus is a given in molar units. So pH of the pure water is equal to 1 into 10 raised to minus 7. So pH is equal to minus log 1 into 10 raised to minus 7 is equal to 7. 7 is the neutral and 0 up to the 7 is the acidic, and more than 7 to 14 is the base or the alkaline. So that is the scale for pH. And what is the last example of pH is equal to 1.9 into 10 raised to minus 13. So pH is equal to minus log 1 into 9 into 10 raised to minus 13. That is the 12.7. So this is the scale for pH. In pH, neutral is defined as the pH of the pure water is equal to 7. It is the neutral is the pH of the pure water. अनुराधा, तुम्ही काय करा, बाकीच्या क्लासमध्ये बाकीचे मुलं जॉईन आहेत बघा, त्यांना कम्युनिकेट करा. तर लेक्चर ऑनलाईन चालू आहे सध्या, तर तुमच्याकडे लिंक वगैरे असेल तर जॉईन व्हा लगेच तुम्ही. हा. What is the scale for pH? Exact 7 is the neutral, or they are the pH of the pure water. The pure water, it contains its neutral value is the 7. And what about the acidic solution? They are having pH which is lower than the 7. What do you mean by acidic solution? They are having the pH which is lower than the 7. And what about the basic solution? They are having the pH which is larger than the 7. Are you getting? What is the scale for pH? Exact 7 is the neutral. Then the acidic solution, they have the pH which is lower than the 7. That means from 0 to 7, which is the acidic one, and more than 7, the pH, when they have the pH which is larger than the 7, it is a basic. The pH scale, it can also use for the pOH, that is they describe the solution of pOH, that is pOH is equal to minus log OH minus. So that is the sum of the pH and pOH, it must be equal 14. दोघांची व्हॅल्यू किती असते? Acid as well as the base, they are having the value is equal to 14. So they are assuming the for room temperature, that is 25 degrees Celsius. Its temperature is at room temperature, they are having the temperature at 25 degrees Celsius. Then the pH scale, for example, to find out H3O plus of the solution, and they had the pOH is equal to 9.37. Then what will be the method how to calculate the pH? Then the example is a H3O plus. So we want to determine the pH. pH is equal to 14 minus what will be the value of pOH, that is 9.37. So the pH of that H3O plus is a 4.63, because they get minus from actual value of the pH, that is 14 minus 9.37, they having the value 4.63. So that will the value which is determined from the pH value minus pOH value, and we are getting 4.63 the value of the pH of the H3O plus solution. Then this in second step, how to determine the H3O plus value? So that is 10 minus pH, that is 10 minus 4.63 is equal to 2.34 into 10 raised to minus 5. So this is the scale for pH, or how to calculate the pH. Then what about the ionization constant? The extent of dissociation of acid or the base into the water, and they get mainly quantified by using the ionization constant. That is the acids, that is HA, that is in aqueous state. Then H2O, that is the base. चला बात अटेंडन्स करून घ्या सगळे जण. सगळ्यांनी अटेंडन्स केली का?
हो सर.
हो सर.
मला बघू द्या किती जणांनी केली. बापू शिंदे, पोपळे, सावंत, घनकर इज देअर. संजना बसे, सुप्रिया पवार, वैभव पवार. I think Anuradha currently she will join. Okay, Anuradha, you do the attendance. Are you joined? हाँ, आपण काय बघत होतो, what do you mean by ionization constant? So here the Ha plus is the acid, H2O is the base, and they producing H3O plus, that is the acid, plus A minus, that is the base. Ha is the undissociated acid into the solution. Then the ionization constant K is the specific equilibrium constant. So Ha plus H2O, that is H3O plus and A minus, that is in aqueous stage. Then the Ka is equal to H3O plus A minus upon Ha, that is H3O plus, that is the conjugate base upon the acid. So Ha is the undissociated acid into the solution. Then ionization constant, that is the Kb, which is the specific equilibrium constant for the bases. That is B plus H2O, they producing the Hb and plus OH minus. That means Kb is equal to Hb plus into OH minus upon B, and they producing the OH minus, which is the conjugate acid oblique B is the base. So B is the undissociated base into the solution. Then what about the polyprotic acid? Some of the acid which contain more than one hydrogen atom. If the atoms of the acids which contains more than one hydrogen atom, that may donated to form H plus ions, and that is called as polyprotic acids. For example of sulfuric acid, here it contains the 2H plus ions. Then S3PO4, that is phosphoric acid, it contains 3H plus ions, and H2CO3, that is the carbonic acid, and which contains 2H plus ions. All acids are called as a polyprotic acid. Why? Because it contains more than one hydrogen atoms. It contains 2H plus ions, 3H plus ions, as well as 2H plus ions. So that acid is known as a polyprotic acids. Polyprotic acids, each H atom has the unique, that is K, associated with its release to form the H plus ions, and they mainly consider the phosphoric acid, then sulfuric acid, as well as the carbonic acids. Then what about the strength of the acids? The acid strength is determined by the combination of the factor, that is the bond polarity, H A. That bond, it must be polar in order to the H atom, and it is to be transferred to the water as a H plus. Then H atom in CH4, it is a non-acidic because CH bond is not the polar, and HCl bond is a HCl in polar, and HCl is a strong acid. HCl is a strong acid. Then what about the strength of the acids? The acid strength is determined the factor, that is the bonds. The stronger the bond, weaker the acid. If the bond will be the strong, acid will be the weak. So it is a harder to the pull away the H atoms, and they forms H plus ions or the H plus atom, that is the HF, hydrochloric acid, then HCl, that is hydrochloric acid, and HBr, the hydrobromine, and HI, the hydrogen. So these are the strengths of the acids. Then oxo acids are those they having the HOZ, that will be the linkage, and they having the electronegativity of the Z, and higher the electronegativity of the Z and stronger the acid. Then what will be the relationship between Ka and the Kb? That is the acid as well as the base, and K is the constant. Ka of an acid and Kb of its conjugate base, and they get mainly related to the acid as well as the base. Ha in aqueous phase plus H2O in liquid phase, they produce A minus in aqueous phase plus H3O plus in aqueous phase. So Ka is equal to A into S3O plus upon Ha, and A minus aqueous plus H2O liquid, they producing the conjugate acid, that is the Ha aqueous plus OH minus aqueous. So Kb is equal to Ha into OH minus upon A. So this will be the conjugate base or the conjugate acid. So here the relationship between the conjugate acid as well as the conjugate base, and they get mainly related to the product of Ka into Kb is equal to Kw. Here the common things get deleted, that is Ka into Kb is equal to A into S3O plus upon Ha, and Ha into OH minus upon A minus. Both get and they having the S3O plus OH minus, and that is called as a Kw. So this is the of any kind of conjugate pair of the acid as well as the base. Then what about the salts of acid as well as the base? When acid and the base they get undergo the exchange reaction, and there is the salt as well as water. That is HX plus MOH. They producing MS is the strong will be the base, get neutralized with the strong acid, and as a result the contains only the salt. That is S plus NaOH. After producing the salt plus H2O. The salts of the acid as well as the bases, they determine the pH of 0.284 molar solution of the sodium acetate, that is the NaCH3COCO. NaCH3COO. NaCH3COO in aqueous plus H2O, and they produce the Na plus CH3COOH and plus OH minus in aqueous state. So here there will be the complete ionic equation, that is Kw upon Ka, and it is producing the 5.56 into 10 raised to minus 10. So how to determine the salts of acid as well as the base? The salts of acid as well as the bases, when acid will be the weak, at that time the salt having the strong base. So according to the stoichiometric amounts, they get combined the solution, and it will be slightly basic. To determine the pH of the solution with NaOH as well as the acetic acid, that is CH3COOH plus NaOH, and they producing the NaCH3COO plus H2O, where the ionic equation get completed. That's why the sodium is a spectator ion, and they does not actively participate in the reaction. The salts of acid as well as the base, where the salt is the bleach is the sodium hypochlorite, that is NaOCl, and they determine the pH of the solution, which containing 1% by the weight of the NaOCl, that is the sodium hypochlorite. So that the Lewis acid and plus 2NH3, they produce AgNH3 plus आवाज येतो ना सर्वांना?
हो येतोय.
हा ठीक आहे.